I didn't see you there. Let me introduce myself. My name is Ernest Rutherford. Many people know me because of my achievements in nuclear physics and discovery of the atomic nucleus. I was born on August 30th in New Zealand as the fourth child in a crowded family of 12 children. Growing up, my family often experienced financial struggles, but that didn't stop me from unleashing my creative potential. My eagerness in academics is what drove me to a scholarship in Canterbury College in 1890. During this time, I was growing more and more curious about finding solid evidence through scientific experimentation. This fueled my passion in sciences even further and allowed me to be invited by Professor J.J. Thomson to collaborate on the study of X-rays. We then went on our separate paths, as I got more interested in radioactivity, and he carried on with his investigation with electrons. Eventually, I left Cambridge to start becoming a professor at McGill University in 1902, where I continued with my interest in radioactive energy. Later, I returned to the University of Manchester as a professor in 1907 and conducted my gold foil experiment, which led to my atomic model and my discovery of nuclear physics. It was also here that I met and collaborated with many future aspiring atomic scientists, Neil Bohr and H.J. Moseley. In 1900, I married Mary Newton and gave birth to a wonderful daughter named Eileen. One of my biggest contributions to science and physics was the discoveries made from my gold foil experiment, which I conducted alongside my colleagues Henry Geiger and Ernest Marsden. This experiment was aimed at reaffirming J.J. Thomson's plum pudding model here and the claims he made about the structure of an atom. In the experiment, I used a radioactive source that emitted alpha particles, which I previously discovered to be positively charged that had a mass lighter than hydrogen, and a lead screen with a slit that the particles would pass through in order to focus the particles into a narrow beam. Then I would have a thin piece of gold foil around a few atoms thick in front of the lead screen and a phosphorescent screen encasing the foil. This screen would be used to detect where the alpha particles landed after coming in contact with the gold foil, because of how the screen emits a burst of light every time a particle strikes the screen. This would allow me to track and observe patterns of where they landed, in addition to drawing conclusions from my experiment. My original hypothesis was that the alpha particles would shoot through the foil very easily, based off my predecessor J.J. Thomson's theory and his atomic model. If according to the plum pudding model, all the positive alpha particles should pass through a negatively charged space with ease. However, what happened next was both a shocking and exciting discovery. As shown here, most alpha particles pass straight through the gold foil, meaning that the atom is made mostly of empty space. Other particles were deflected slightly, implying that there are other positive charges in the atom to react with the positively charged alpha particles. Few particles bounce back at extreme angles, and even directly bouncing back towards the source. This meant that there was a positively charged target particle that was also pretty heavy in mass, which could lead to such a strong rebound. It was these experiment results that led to the discovery of the positive central mass of an atom, later to be named the nucleus. Other discoveries made from the experiments include the protons in it and how an atom was majorly consisted of empty space. These three main discoveries would be the major points of focus in my version of the atomic model, as shown here. My Rutherford model consisted of a positive nucleus, empty space, and an equal number of protons circling the nucleus as electrons. Many people said that my discovery was the discovery of the century because of how it changed people's understanding of the atom entirely and proposed new knowledge to contribute to the atomic theory. I expand the knowledge of the atom based off my predecessor J.J. Thomson, who brought forth the claim that an atom contains negative charge, accompanied by his plum pudding model. His model showed that the electrons were embedded in a solid spherical shape consisting of positive charge. So in my experiment, I disproved and discovered the flaws in his model, leading to my current model. In contrast to Thomson's model, my model indicates how the electron orbits in empty space around a central positive solid core, aka the nucleus. One thing to mention is that while I did make developments in atomic theory, all of it was made possible by building off the knowledge already there. All my discoveries led to my altered version of Thomson's model. However, there are multiple scientists before me that also followed a similar process of expanding knowledge based off of their predecessor. Yet, the change in development in atomic theory doesn't stop there. As you would probably all know by now, Niels Bohr would be the next scientist to make changes and new discoveries, bring forth his version of the atomic model. As a scientist, one of the most important things for me to understand is the constant process of scientific development, as new experiments are conducted and conclusions drawn. The atomic theory is but one of many representations of scientists working together throughout the course of history, relying on the basis of one another's previous work in order to expand and find answers to a shared problem about the world. The infinite possibilities in the world is what makes science such a wonderful thing to explore with some people, and how it shapes our understanding of the world over decades and centuries. The answers to scientific problems about the world are already there, but just need someone to discover and conceptualize it.